So, alright, so we'll just go over 8, 9, then we'll do 8, 9, 8, 21, and 8, 24. And so 8, 9, we got this equation. We got I of t is equal to t cubed e to the minus 2t a. V of t is equal to L di dt, and L is equal to 0.125, and this is Henry's. A asks us to find the voltage, V of t, and so how do we do that? We're given this voltage equation, right? We're given L, and we're given I. So all V of t is L times the derivative of I of t. So the first step is to take the derivative of I of t with respect to t. So what do we have to do? We got to do the product rule, right? So the product rule is the first derivative of the first function times the second function plus the derivative of the second function plus times the first function. So the first function in I of t is what? T to the third. And the second one is e to the negative 2t, right? This one right here. So, yeah, we will. So, let's just define that. So, we'll say f of x is equal to t cubed, and g of x is equal to e to the minus 2t. And we define the product rule. Oh, yeah, I'm sorry. Good call. Function of t and another function of t. You're right. So then the derivative of the product rule says f prime of t times g of t plus, that's x, but it's t, plus f of t times g prime of t. So doing that, can we figure out what the derivative of I of t is? It doesn't matter the order. The quotient rule, which is something that you'll learn in other calculus classes, will matter the order of these two. But because they're just added to each other, the order doesn't matter. Yeah.
You just do, like, for the quotient rule, the first thing you see over the times the second,
Yeah.
Plus, or
minus, exactly. But this, it doesn't really matter with the product rule. This is, either way, you're good. So let's do this. F prime of t is what? 3t squared times g of t, which is just that, e to the minus 2t, plus f of t, which is just t cubed, times g prime, which is what? Yep. So this is going to be negative 2t cubed e to the negative 2t. And this is the derivative. So if we want to find v of t, we just multiply L, which is this value right here, 0.125. So we Huh? So then it's just multiplied by our derivative of I of t, which is 3t squared e to the minus 2t minus what? Exactly, yeah. And we'll do that. T cubed e to the minus 2t. And then exactly what you said. So part B wants us to find the value of I of t when v of t is equal to 0. So we would set this value equal to 0 and find the value of t for when that's true. So if we want to do that, we want to clean v of t up a little bit, right? So we'll clean it up by factoring out, can factor out an e term, and actually to make it a little easier to see, we'll keep the t terms in there. Just because all we'll have to handle, we'll see that e to the minus 2t never goes to 0, so we only have to handle the inner term. And I'll show you.
So it's never 0.
E to a negative power will never go to 0. Because you'll think about it as just 1. E to the negative is just 1 over e to some value t, right? No matter what value you plug in for that value is never going to go to 0, because this is always a constant term. You're never going to be able to set this term equal to 0. So even if you plugged in e of 0, exactly. So if you plugged in e to the 0 where 0 is t, that's still 1, right? So you're not going to get that term equal to 0. So let's do b. So b now, we have v of t is equal to 0.125 e to the minus 2t, which we factored out. So we're left with 3t squared minus 2t cubed. So this term, when we plug in t, will never go to 0. To 0. But this term, we can manipulate to 0, right? So we just have to set 3t squared minus 2t cubed equal to 0, and this whole equation, v of t, will be equal to 0. So how do we do that? We can factor out a t squared, right? So we'll do t squared times 3 minus 2t is equal to 0. So we have t equal to 0 when? When t equals 3/2 and when t is equal to 0, right? So when t is equal to 0, that's 1. And we can see easily right here by plugging in 0 there, this equation goes to 0. Then we'll set this equation, 3 minus 2t equal to 0, which is 3 equals 2t. Divide 2, we have t equals to 3/2. So there are two values of t that's going to set this equation equal to 0. And part C asks to sketch this. Now we know a couple. It asks you to sketch I of t, but there's a reason. That's it, exactly. It's equal to that value. And we're given, what's it ask for? Since V0 at T1 is a 1.5, which is what we found, is a local maximum, right? We have a local min and we have local maxes, which is the derivative. So when we take the derivative and set the derivative equal to 0, which is what we did by finding V, then we found our local mins and our local max. And then we just have to know the general shape of the exponential function. You get something that looked like this. So at v0, 0, at time 0, we have it at 0 value. So that will be our local min. And then we have a local max at 3/2 t. So this is going to look something like this.
Yeah, I got that.
There you go.
I didn't draw the other half.
That's fine.
Now we can go.
Now let's do 21 and 24. These ones are a little harder.
No, it's just hard.
It's really not. It may be a little hard because you guys didn't take integrals, and this is kind of going backwards, right? We're given a derivative, and we're given a graph of a derivative, and we kind of want to go backwards, right? All right, that's fine. So 21 says, given the plot of the voltage, and we're given V of t is equal to L di dt, and P of t is equal to V of t times I of t, and L is equal to 2, I0 is equal to 0, and P0 is equal to 0. This is what we were given. Right? And we were given this graph of V of t. So we go from 0 to 1, this is 2, this is 3, 4, and 5. So it seems and this value is 6. So at every 1 second interval, we have a switch. We pretty much have a square pulse wave right now. So it's going off and on. It's like turning a light off and on every second. So we have an amplitude. It's pretty much a switch. Unless you have it in a circuit with a capacitance, then this may look a little curved because the capacitor needs to charge up. So there's going to have some time delay to it. Okay, but well, even this inductance, it would have a little bit of a curve as well, but this is an ideal situation. This is ideal. This isn't practical, this is ideal. Alright, so we know that V of t is equal to L di dt, right? So we pretty much know that V of t, the derivative of I of t is right here. Yeah. So this is the slope, right? So V of t is really the slope of I of t. And that's what we're asked to find. We're asked to find I of t, right? Plot I of t. So we're given right here is the slope. But we're also given a constant as well. So the first thing I would do is divide this by L. And L is equal to 2, right? So we could actually rewrite this. So if we were to rewrite this, we know that from the interval from 0 to 1, V of t is equal to what? V of t is equal to 6, right? But if we divide it by L now, divide it by 2, V of t is now equal to 3, right? So if we divided this whole function up by 2, which is what L is, so V of t at this interval right here, we divide that interval by 2, what are we going to get? That same thing, but at 3, right? So let's just redraw that then. So we'll just redraw this a little smaller. So pretty much we're just taking half of this original graph, and this now equals the slope, right? So this is 3. So now we have 3 is equal to L di dt from the intervals. Actually, let me. Oh, no. I'm sorry.
So 3 equals di dt. Why does 3 equal?
Because right here, but it's only from the interval from 0 to 1, 2 to 3, and 4 to 5. So we can kind of make this look like a piecewise function, right? So V of t is equal to 3 from the time interval 0 less than or equal to t less than or equal to 1, when it's 2 less than or equal to t less than or equal to 3, and then 4 to 5, right? 4 less than t less than or equal to 5. So under these time interval conditions, the V of t is equal to 3. What's V of t equal to the rest of the time? 0. So it's equal to 0, I'll say otherwise. So now, what is this saying? We have this value over this time interval, and this is equal to the derivative of I with respect to t. Well, if we take the derivative of I at that point or at that time interval, we're finding the slope at that time interval, right? So now we can think of, because if we come back to the fundamentals of a derivative, when you take a derivative of, let's say, an arbitrary, my fault, let me just draw this and I'll go back. So let's say we have a parabola, right? If we take the derivative at this point right here, that's going to give us what? It's going to give us 0, which is the slope of the tangent line at that point, right? So if we took the derivative at this point, it might be 1, 2, some value, and that's the slope of the tangent line at that point. So when you take the derivative, you're finding the slope of the curve of that line. So going back to this now, the derivative, which is V of t, the derivative of I of t is saying that we now have a slope of 3 from the interval from 0 to 1. So what's that going to look like? What's I of t going to look like now?
Alright, so I got that, but if you actually take the slope at 0 to 1, it's 0.
No. The slope of v of t, if you took the derivative of this. But v of t is the slope. Because we're going backwards, right?
Oh, so this is the first derivative?
This is the first derivative here. Because look at the equation. V of t is equal to the first derivative. So if we wanted I of t, if we want to graph I of t, right, this is equal to the integral of v of t. Or the antiderivative. So, you don't get it? Alright. So, let's use this. Let's use I of t. Alright, so now we have I of t. Well, the equation
Wait. I'm confused with all the variables.
with all of the variables. Just the general, alright,
Yeah, like, why are they giving us all of
all of what? These values, this P of t, L of t. Let's not focus on that right now. Let's focus specifically on the first task at hand, which is finding I of t, right? And sketching I of t.
I of t, that's what we're doing.
That's what we're finding. It says that it asks us to find plots of I of t and P of t. Well, in order to find P of t, we know V of t. We need to find I of t. So we have to first find I of t. Because it's given to us right here.
On the graph.
Yeah. And look, I generated the equation for it right here.
Oh, okay. So V of t is that in the graph. So now we're going to use V of t to find I of t.
Exactly. And we know
How do we know the formula for I of t?
right here.
Where?
This, my fault. I pointed to it on here and you couldn't see that.
Oh,
Okay, so this di dt is the derivative of I of t, right? So let's just get it first in terms of di dt, and then we'll go backwards, right? To find I of t, which is integration. So the first step that I do,
I'm just.
Yeah, that's what I was telling you before, like the L becomes a meaningless term.
Oh,
it's not meaningless though. L is not meaningless because L affects the slope, right? So we divide, L is this value too. It's just some value. So V of, and it's all represented, if you take electrical engineering or if you go into,
That's what I'm doing, and I'm lost.
you'll learn it. Circuits, I didn't know this when I was here. Like, you guys are probably further along than I was when I got in here. So, I mean, this class is only going to help you guys get better and learn and understand the stuff more. So it's going to be a little unfamiliar now, and you'll see this class is kind of just an introductory so that you see the circuits, you understand it a little bit, and be like, all right, I saw that. I kind of know how the math works behind that, and then you'll have to derive the math yourself. So, but this, they give you the circuit, and then they give you pretty much the voltage, what the voltage will look like right here. That's what V is. It's the voltage.
I wish they framed it in the application sense, because when I look at these problems, I think of it from a math perspective, but I can't connect the dots.
Yeah.
Application. It is. It's tough, and I think that's.
It should be all application, right?
Yeah.
Don't put any freaking numbers in it.
But you need to know the numbers.
Yeah, but really?
I mean,
Right now, we need to know numbers. It should be the app.
but in order to
Formula. So
Yeah, we get the
now.
formulas.
Well, I mean, that's what your other math classes are supposed to do. And this is kind of just to show you that this math will be applied. You don't understand the application, but it will be applied in these certain, the steps of these are going to be steps that you will see and you'll have to do.
I'm still trying to figure out why the integral of like sine 8x times cosine.
Very important.
That was
I'm still using it. If you get in higher level linear algebra classes, higher level, like graduate level classes, integrations of sines and cosines are actually
Classes, when do you use it in real life?
all that. I mean, telecommunications, right? All waveforms are some types of sinusoids,
I
and
understand that. That makes so much sense. Not this.
You'll learn it. This is just a natural progression. You'll get through it. Just be patient now. You still got 4 more years of it. You still got 4 more years of it, and you'll probably still graduate before I will. So, I don't know. I might be here for I might be here for 5 years too. Yeah. I'm still doing doctorate. Yeah. I'm just a glutton for punishment. That's what it is.
Okay.
All right, let's go. Let's go back. Yeah, let's go back to the steps. L is 2, right? So this represents, what does V represent now?
V represents the derivative of I of t.
V is the derivative of I of t. And what is the derivative of I of t?
I don't know.
It's the slope of I of t.
Oh, well, yeah, but I mean...
That's what this is. That's all this is representing then. That's all V of t is representing. That means this value... That means that V of t is equal to the slope of I of t. Let me write that out. So V of t, but we can derive it, right, from the slope. So V of t is just equal to the slope, I should say V of t over L, is equal to the slope of I of t. On this side it is. Because we originally have V of t, right? Because if we plugged in V of t plugged in is 6, right? Let me rewrite this. So this graph right here is V of t over L. That's what this graph is.
V of t over L. Right. But isn't it 3?
Exactly. It is 3. That's all it is. So that's saying that the slope of I of t now, if V of t over L is the slope of I of t, then let's write out I of t. That means I of t from the interval of... Alright, I'll just say I. 0 less than t less than or equal to 1. So from 0 less than t, that says I of t is equal to the slope, or the slope of I of t is equal to Vt over L through this interval. So that means the slope, and if we're going to a regular line, y is equal to mx plus b, right? Where m is the slope. So that means 3 from 0 to 1 is the slope of I of t. So then we can write this as 3x plus b. How do we know b? We go to the initial condition where it says I of 0 is equal to 0 for that interval. All right, let's go. No, this is definitely confusing.
Okay.
All right, so let's go back to,
Okay.
you understand step 1, right?
Yeah.
All right, so
To get V of t by, well, to get di over dt by itself.
exactly.
So the derivative is equal to v over vt over L.
And what does that
And
represent?
how L is 2 and the slope of v of t is 6.
So 6 divided by 2. Yep.
And then we said that it's 3 from this interval, this interval, this interval, and it's 0 from like 1 to 2 and 3 to 4.
So what's that mean then? That just means that
That just means it's a line.
it's a line. Exactly. That means we have a slope. That's saying that V of t is the slope of I of t. So if we're given the slope and it's only a constant, that means m is only a constant, so we have a line now. So we can now write I of t as a line, and that slope 3 is positive, so we're going to have a positive slope from this interval.
3 is the slope, okay? And then x plus the intercept. How come the intercept is 0 just because they said it?
Well, that's what they gave us. We're assuming,
That's what that means?
yeah, that means the y-intercept. That means for this interval, right, from 0 to 1, at I of 0 is 0. So the first point of I of 0 we can plot right here. And we know that from this interval, From 0 to 1, it goes up 3 over 1. Exactly. So from 3, it's going up 3 over 1. Now, let's look at the next step, from 1 to 2. The slope from 1 to 2 is 0, right? So what's the slope of 0 look like? Just a straight line, right? So we have a straight line from 0 to 2. And now from 2 to 3, we have another slope of 3, right? Right. So then this goes up. So if we go from 2 to 3, our slope again is 3.
But based on your formula, it should be 6.
Yes, because B is
So from 2 to 3 is
0, right? Because this is a what? So this will go from 2. Actually, no. It goes from here, but this equation was just for this time interval, right?
how does it look like?
Was just for 0 to 1. So from 2 to 3 now, we're actually extending because we have a value of 2. Our value of 2 is 3 because the slope was 0 at that time interval. So we're just extending now from that same 2 point because we're going to a different time interval.
Wasn't that fine, maybe? You said our value is 2 to 3?
Our value of 2 on I of t is 3,
Based on what?
based off of the slope being 0 from that time interval. Because there isn't a
Because the slope is 0,
between 1 and 2, which makes 2 the starting point of the next time interval, which the next time interval, where the slope of the next time interval is 3. So we're just continuing from that 2 point. And all we really need to know after our initial point is
So we think
the slope. If we took the integral of this, or no, if we took the derivative of di dt, we would get this. We would get vi via, yeah, over L, exactly. So now from 3 to 4, our slope again is 0, right? Our slope is 0, so this again is another horizontal line. So from 3 to 4, we have another horizontal line, and 4 to 5, we have another slope of 3, right? Why? Because the derivative right here, huh? So it ends at 9, exactly. So it ends at 9. So this goes to 9, and so from 4 to 5, we have this go from, so that goes to 9, that goes to 6, that goes to 3. So what do we do now? And does that make sense? I of t? You could do this? Okay, good. So now,
Okay, B of t equals the slope of I of t,
yes,
but there's an L, so you got to
it's L divide.
So I of t equals B of t over L,
Mm-hmm.
and then like it says that's like from the graph,
Yep.
and then you just you find the equation for I of t,
Yep.
and then you just find that, and now we do the next step.
Exactly. And now we find P.
You found that the slope at all is different.
It's just 3x, right? Because B is 0.
No, because anytime you change the x value,
You're changing your y-intercept.
right?
And the only way you would know that, you just need to have an initial condition. The initial condition at v of 0. And you could rewrite b. This will not be the same for all of the intervals. This b value will vary for each one. But the reason, all you have to know, though, is from that point at 2, this line this line goes to that point, right? So 3 is still the value at 2. And we know at 2 to 3, we have a slope of 3. So we don't necessarily need to know B, but we can find it from this information given. If we were to, because we know that this will have to have a y-intercept somewhere, right? Yeah, exactly. So pretty much all this is shifted over from here, right? So it's kind of just shifted over.
So I have this graph that you have.
All right?
I got it.
A completely different way? All right. That's fine. I mean, as long as the answer is right, you derived it a different way, the answer is right.
I was on point with you up until you did 3x plus b.
All right, don't worry about that then. Just don't worry about that.
This is the part that confused me. I just started throwing.
This part's actually pretty easy. This this isn't the integral. P of t. Yeah, you can multiply graphs. Graphs are just values, right? Graphs are just values along time with respect to time. Just like you can multiply 2 by 2 times 2, well, you can multiply 2 times 2 because 2 at t1 is 2, and 2 at t2 is 2.
Is this just the same as the BT graph
Times it. Exactly. So this is all it is. So we have a representation. So what we have here is so let's draw both of them over top of each other, right? So v of t is just equal to 6 from 0 to 1, 0, 2 to 3, 4 to 5. Now this is v of t. I of t is equal to, this goes to 3, so from 0 to 1, then it goes to 0 to, that's 2, then 6, so from 2 to 3, we go to 6, then from 3 to 4, we stay at 6, then from 4 to 5, we go from 6 to 9. Right? So all we have to do is literally multiply each one of these time intervals to each other. And because this is constant, all this is doing is multiplying this slope by 6, right? So you can think of this equation as I of t equation for this first time interval is equal to what? No, just I of t. Let's just say for this time interval. It's 3t plus 0. So now all we do is multiply I of t by v of t, which is 6. So this becomes what?
V of t is 6. Okay.
So what's p? All right, let me actually rewrite this. Exactly. P of t is equal to I of t times v of t. And for the first time interval, I of t is equal to what? 3t, right? From 0 to 1. So this is only for the time interval 1. And v of t is what from that interval? 6. So this is going to look like what? 18, exactly. So this is going to be 18t. So 18t is just a straight line with a slope of 18 versus 3. So it magnified the slope. That's all it did. And so we can redraw that time interval now. It's not, because now it's a slope. So from 0 to 1, we have 18t, which looks like that. And this value is 18. Right? Now from 1 to 2, v of t is 0, right? So from the interval 1 to 2, v of t is equal to 0. So it's 0, right?
So 18.
So this is just 0 from 1 to 2.
0 to 1.
Yup. So from 2 to 3 now, this is going to start at 18 and go with another slope of 18 So this will go to 36. Because this is our starting point, right? 2 at this value is equal to 3. 3 times 6 is 18.
It doesn't connect them at the...
Well, it would if this was, that's 0, right? So we can literally just multiply points. So if we wanted to know our starting point right here at t equals 2, let's go to t equals 2. T equals 2 here is valued at what? What's that value right there? This value at t equals 2. I of t at t equals 2. Any takers? Just I of t at 2.
Why is it going to 30?
Why is it going to? That's what I'm explaining. So I of t,
I thought we plugged it in.
you can. Look, we could just plug in at 2. Let's say p of 2 at the value 2 is equal to I of 2 times v of 2. So I of 2 is 3. We know that. So 3 times v of 2 is what? 6. It's, well, we're going to say the closest the rightmost point to 2. So 2.00000, whatever.
Wait, how did we get sorry. Okay. So 0 to 1, right?
Mm-hmm.
So from 0, did we plug in 0 and plug in 1? No. Plug in
You
1.
can't, but you can.
Plug in 1, then you plug in 2, then you plug in 3, then you plug in 4.
And that's the easy way. That's an easy way of doing it.
Okay. So 3 is B of T is constant at 6, right?
Exactly.
Right. So it'll always be like 3 times 2, 3 times 1. Okay. Okay. So the first one is 0. Okay. 1 is 18. Okay. So 2 is 6 times 6. So okay. And then we're gonna okay.
Just gotta talk it out. I didn't even have to teach. You knew it. You just talked it out. This is identical to 23. It's identical to 23.
This is how we find.
Let's
Why
see.
are we going down?
Wait, it's not identical.
I mean, it's close. No. The graphs, the process is identical. The process, not the graphs are not identical.
So why are we going down there? Down
All right. Now let's do the next time interval, right? 3 to 4. Well, from
Wait, but why?
why
Why is it 1 to 2?
why 1 to 2 is 0? Because look,
So like this.
v of t is 0 from 1 to 2. So 0 times anything is 0.
I thought it's constant. It's 6.
No, it's constant at 6.
From 0 to 1. So this time interval,
1 to 2 is
0,
0.
0 plugged into that. It doesn't matter what v of t is.
And then 2 to 3 is 6.
Yup, 6 times another slope. 6 times another slope is just amplifying that slope, right? So it's still going to be a slope of 18, but the starting point you have to look at.
So 0 dots.
Yeah, just draw dots at the points. You could draw a dot at a half, so you could draw a dot here, you could draw a dot here, dot here. Just find points and you'll get the general shape of it. But to just understand that the slope, you can multiply a slope by a constant and it amplifies that slope, right?
Is this 72?
That top value is not 72. 56.
4?
So 4, so look at 4. So from 3 to 4, this is going to be 0, right? Because 3 to 4 is 0. So from 4, if we take 4, it's 6. 6 times 6 is what?
4 times 3 is 12.
4 times 3 is 12. Where are you getting a 4 and 3?
No, you're multiplying the two graphs together.
You're multiplying the two graphs. We're not, that's time. This axis right here is time. These are our t values. Yeah, I should have included. Yup, and then the 4 on v of t is 6 as well. So 6 times 6 is equal to 36, right? And this still has a slope of 18. So this will go to 50, this will go to 54. Because let's just do it right here at 5. 5 is 9, right?
9.
So it would be 9 times 6. 54.
Wait, but what about
4,
four?
just replace,
Still 36.
just replace,
Yeah, because if you look at the time interval, it's the same slope. It's the same point at that 3. So if you multiply 3
And
times
it stays
3.
the same.
Right.
Yeah.
It's the same spot again at 4.
exactly.
Got it.
You got it? All right.
So 3 is 30.
And that's,
And you come back down because it stays like that before. And you plug it all in.
what do you mean plug it all in?
Put in all the numbers.
Oh, you want me to write it out?
Yeah.
I don't have enough space
Just plug,
on this.
Okay, just plug in a couple. Oh, wait, you did it already.
Yeah, right here. So I said I of t for 2 seconds is 3 times 6. And then this will be p. This one is for p of 2. And this one is p of, what we say, 4, right? No, 5. Yeah.